Hello everyone. This is Professor Deepika from SAVI Institute of Technology, Department of Electrical and Electronics Engineering. So in today's video, we are going to discuss about some topics related to the electric traction. So in that we are going to discuss about the mechanics of train movement, like how will be the train movement will be there. So that we are going to study here. So coming to the mechanics of train movement, essential driving mechanism of an electric locomotive is shown below. So you can see here how actually the train movement will be happening means, so as it is a electric traction means there will be an electric motor which is powered by an electrical energy. So we know that a motor is nothing but what, which is going to convert the electrical energy into a mechanical energy. So that mechanical energy we could obtain from the shaft of the motor, correct? So whatever the shaft of the motor is there, so that is giving us a mechanical energy, that is the mechanical rotation. So therefore you can see here, so this is the armature of the traction motor. So this armature of the traction motor what we are having, so this will be again that means the armature of the traction motor is having a shaft. To the same shaft we are going to fix the pinion. So there will be a pinion moment. That means what? When there is a circular motion in the pinion moment, there will be again that will be given to the gear wheel. Okay, so therefore the pinion will be it is something like it is transmitting the mechanical energy to the other wheels. Okay, so that is something like a pinion. So therefore the pinion will be again attached to the gear wheel. So when pinion rotates, the gear wheel will also be rotating in the opposite direction. So therefore you can observe here, if this is the traction motor rotation and the pinion rotation, the gear wheel and the road wheel will be rotating in the opposite direction. So therefore when the pinion of motor rotates, the gear wheel also rotates. So when gear wheel rotates, so this gear transmits the mechanical energy to the road wheel. Hence we could obtain the mechanical motion. So this is how the train movement will be happening. That means what? There will be a traction motor. So the traction motor is rotating, and to the that means the shaft will be usually at the armature of the traction motor. So when the shaft rotates, so the pinion will be attached to the same shaft. So again when shaft rotates, the pinion will also be rotating, and when the pinion rotates, the gear will also rotates. So that means the mechanical energy will be transmitting from motor to a wheel. Then when the gear wheel rotates, again the road wheel also is going to rotate. So hence hence the movement of the train will be possible. So therefore the diameter of the pinion of motor will be d dash. You can observe here it is d dash, and small letter d, what you can see here, so this is the diameter of the gear wheel, and capital letter D is the diameter of the road wheel, and whatever the F dash you can see, so this is the tractive force at the edge of the pinion moment. That means what? The force will be transmitting here. So therefore this is the force at the pinion of motor, and by this mechanism the force will be transmitted to the road wheel. So that will be called as F, and these two forces will be in the same direction. So you can see here, so this is how actually the construction will be there in the train. That means there will be a traction motor. So when the traction rotates, there will be again the suspension tube, so to which the wheels are attached. And you can see here, so this is the armature drive shaft, and this armature drive shaft is attached to the pinion. Okay, so you can see here, so this is something like a pinion, and when the pinion rotates, again the pinion will be attached to the gear wheel. Hence when the gear wheel rotates, the road wheel is also going to rotate. So in this way actually the movement of the train is possible. So this is how the mechanics of train movement will be there. Now let us see, the armature of driving motor has a pinion of diameter d dash. Attached to it, the tractive force at the edge of the pinion is transferred to the driving wheel by means of a gear wheel. So therefore, let's small letter d is a diameter of gear wheel in meter, and capital letter D be the diameter of driving wheel in meter. So let the driving motor exert a torque in torque T in Newton meter. So torque is nothing but what? It is the twisting moment or the rotational moment, correct? So this is that means the driving motor exert a torque. So that is nothing but the T. So therefore, the tractive effort at the edge of the pinion can be written as, we know that torque is nothing but, as I told you, it is the twisting motion or twisting action. So due to that means the torque formula is nothing but what? It is nothing but force into distance, correct? So this is nothing but the formula for the torque. So if I take the torque or torque at the edge of the pinion, so this is how I am going to take. So at this part, I am going to take the torque. So then how can I write over here? So this is nothing but a force into distance. So this is nothing but a force, okay? And the distance is nothing but what? It is the distance from the shaft of the motor to the edge of the pinion, correct? So therefore, what is the distance over here? So this is nothing but the d dash by 2. If d dash is the diameter, then of course the radius will be, or the distance will be d dash by 2. Hence I have written as d dash by 2. Then if I want the tractive force at that point, then I can rewrite it as F dash. So here capital letter T is nothing but the torque and F dash is nothing but the tractive effort at the edge of the pinion. So therefore I can write it as F dash is equals to 2T by B dash. So next, the torque at the gear wheel. Okay, it is same thing here. So you can see here, if I want to know the torque at the gear wheel. So this is the gear wheel, right? So the torque at the gear wheel is again nothing but what? It is nothing but again F dash, correct? So this is nothing but F dash into D by 2, small letter D by 2. And if I want to know that the tractive effort or torque at the road wheel, then this will be the road wheel. So therefore here the capital letter F will be the force tractive effort here. So therefore this is nothing but the torque at the road wheel is nothing but what? It is nothing but capital letter D by 2 into F. Okay, so this is nothing but the torque at the gear wheel and the torque at the road wheel. Hence I have also written the tractive effort at the road wheel as well as at the edge of the pinion. Then efficiency of transmission. So what is efficiency? It is nothing but what? Output power divided by input power. So what is the formula for output power? Usually the power in terms of mechanical means what? It is nothing but torque into angular speed. So the torque into angular speed is nothing but what? Efficiency. So output power is nothing but what? You can see here. So this is the eta is nothing but what? Efficiency of transmission. So where from way to way the transmission is happening, the transmission is happening from pinion to the or the motor to the road and the gear wheel, correct? So therefore for this road wheel, where will be the input? Input will be coming from the gear wheel, correct? So because the gear wheel attached to pinion, so therefore whatever the input at the motor will be there, so the same will be at the gear wheel. And this has to be transferred to the road wheel. So therefore the output power will be at the road wheel and the input power will be at the gear wheel. Hence we have written it as output power is nothing but, it is nothing but torque at the road wheel into angular speed of road wheel divided by torque at the gear wheel or at the edge of the pinion into angular speed of road wheel. So usually we know that as rotating. So therefore the angular speed will be almost same. That is the angular speed of road wheel will be same as the angular speed of gear wheel. Hence we are taking it as common. So therefore angular speed, that is omega and omega, is going to cancel. So next I am going to substitute for the torque. TR is nothing but what? You know here it is nothing but FD by 2. And what is TG? TG is nothing but you can see here it is 2TG, F dash into D by 2. On reciprocaling, we can write it as 2 by F dash into D. Next here, 2 get cancelled and we have left out with FD by F dash into D. So next, tractive effort transfer to the driving wheel. Okay, so now we have written the efficiency of the transmission. Then how can I write the tractive effort transfer to the driving wheel? So you can see here, so this is the formula for efficiency, and I want to know what is the tractive effort transferred to the driving wheel. That means what? It is F dash. So therefore, sorry, it is F, that is driving wheel means road wheel, correct? So the tractive effort transferred to the road wheel is nothing but capital letter F. On the rearranging, I could write it as efficiency, that is eta into F dash D divided by capital letter D. Let us take d by d separate. So here, let it be as it is d by d, and I know what is f dash. So what is f dash? So f dash is nothing but 2t by d dash, which is nothing but tractive effort at the edge of the pinion, which is nothing but 2t by d dash. So therefore, I have written like this, and I'm making d by d dash as one term and 2 by d as another term. Let I'm assuming that the eta t 2 gamma by d, whereas gamma is nothing but what? It is nothing but Gauge ratio. Why it is called as Gauge ratio? Because there will be diameter at the Gauge ratio can be written as d by d dash, whereas small letter d is nothing but the small letter d is nothing but what? It is the diameter of the gear wheel, whereas capital small letter d dash is again nothing but the it is nothing but the diameter of the shaft, correct? So that is how I am assuming that gamma is Gauge ratio. So therefore, we can replace as F is equals to eta t divided by 2 gamma by d. So this formula is very important. So what it is nothing but, it is nothing but tractive effort transferred to the driving wheel, which is nothing but eta t divided by 2 gamma d. So this is how the bogie image will be there in the electric traction system. You can observe here, so there will be a driving motor. So then again the driving motor will be attached to the brakes as well as to the wheels also. So therefore, when the shaft rotate again, when the shaft rotates, that is pinion also rotates, hence the gear wheel rotate, hence the road wheel is also going to rotate. You can see here. So when if this is the track, then like this we are going to place the bogie like this. Upon the bogie we are going to place the coach of the train. So therefore, what happens when the motor rotates, the shaft is going to rotate. That means the pinion also rotates, hence the gear wheel rotate, hence the road wheel is going to rotate. So this is how the practical image will be there. So next, let's see some of the definitions related, and these are very important from exam point of view. So first one, we have to know what is coefficient of adhesion. So what is adhesion? Adhesion is nothing but what? It is nothing but termed as the addition. Nothing but what? It is nothing but the the ratio of tractive effort. What here that the rest to move the wheel, we have to provide the tractive effort. That is, we have to provide external force that will be again given by the motor. Hence, the ratio of tractive effort to slip the wheel, that is to move the wheels on the track, and the adhesive weight. So that we will see later what is adhesive weight. So this ratio will be taken as coefficient of adhesion, because there will be a weight of the train and there will be a attractive force between the wheels and the track. So therefore, this ratio will be taken as coefficient of adhesion, and it is actually represented by mu. Or coefficient of adhesion can also be defined as the ratio of maximum tractive effort that can be applied without slipping of wheels to the adhesive weight is called as, that is weight on the driving wheels is called as coefficient of adhesion. So this is also the another definition of the coefficient of adhesion. So then maximum frictional force between the driving wheel and track, we can write it as mu into capital letter W, where mu is nothing but coefficient of adhesion between driving wheel and the track, and the capital letter W is nothing but weight of train on the driving axle. So therefore what happens if the friction between them is greater, that is if the tractional if the force what we are having, so the tractive effort, if it is greater than mu into W, that is maximum frictional force between the driving wheel and track, then actually what happens, the wheel will not slip on the track. So it should be less than or equal to the that is for motion of train without slipping. So this tractive effort should be less than or equal to the product of mu into W, that is the maximum frictional force. In no case it should not be greater than mu into W. And magnitude of tractive effort that can be employed for the propulsion will be again depends upon the weight coming over the driving wheels and the coefficient of adhesion between the driving wheel and the track. So you can see here, so this is the force formula, right? So therefore this force will be depend on the coefficient of adhesion and the adhesive weight. So this will be again depending, this is how it is depending. Then the coefficient of adhesion reduces with the increases in speed. Yes, right. If the speed increases, then the attractive force between the attractive force between the wheels and the track is going to reduce. So this is the actually the table you can see here. With the increase in speed, you can observe here the coefficient of adhesion is going to reduce. Okay, so if speed increases, the coefficient of addition is reduces. If it is 0, then usually it is 0.25, and if we keep on increasing the speed, then coefficient of addition is going to reduce. So coefficient of addition with clean and dry rails. If it is clean and dry rails, it will be 0.25. If it is wet or greasy rail, then it may be 0.08. Okay, then electric traction is advantageous over the steam traction. Why? Because it has a greater adhesive weight when compared to the steam traction, and in a motor coach 100% of weight is on the driving wheel. So whatever the coach weight is there, so whole weight will be there on the driving wheel, hence we will have the good type of adhesion. So next, in an electric locomotive, 70%, whereas in a steam locomotive, it is less than 50%. Okay, so this is why the electric traction is advantageous than the steam traction. So next we have to know what is dead weight. So these are very important in the problem. So we have to know what is coefficient of adhesion, we have to know what is adhesive weight, we have to know dead weight and all. So first let's see what is dead weight. Dead weight is nothing but what? It is the total weight of locomotive and train to be pulled by the locomotive. That means what? It is the whole weight we are saying. So it is the total weight of locomotive, means it is the whole locomotive, means what? It will be usually the coach and all, and the train. So the train weight, coach weight, everything should be pulled by the locomotive is known as dead weight. That means what? Here it will be pulled by the motor. So therefore the total weight of locomotive and train to be pulled by the locomotive is called as dead weight. And what is accelerating weight? The dead weight of train, that is the weight of the locomotive and train, can be considered to be divided into two parts. That means it is usually of two parts. One thing, the weight which requires angular acceleration, such as weight of wheels, axles, gear, etc. So if we look at the motion of the train, usually there will be a two types of acceleration. One is the angular acceleration. You could see the angular acceleration at the wheels, at the gears, and at the axles. Okay, so this is one of the weight that is called as accelerating weight, that is angular acceleration weight. And the second one, the weight which requires linear acceleration. So hence that means what? Usually there will be a linear acceleration in the train, as well as there will be a due to these two dead weight, we are only considering the angular acceleration, but in some part there is a linear acceleration also. Hence, the dead weight will also be, that is the accelerating weight will be greater than the dead weight. Hence, the effective weight which is greater than the dead weight is called as the accelerating weight. So it is usually, we usually tell that accelerating weight will be 5 to 10%, usually 10% more than the dead weight. So therefore, the dead weight, it is considering only the accelerating weight. But if we consider the linear acceleration also, then the weight is going to increase. So that weight we call it as, that actual weight we call it as accelerating weight. Next, we have adhesive weight. So the total weight to be carried on the driving wheels, which is known as adhesive weight. So if the weight is carried by the locomotive, then we call it as dead weight. If we consider the dead weight as well as the linear acceleration weight, then we call it as accelerating weight. The adhesive weight means it is total weight to be carried on the driving wheels. That is the road wheels what we are calling. So upon the road wheel, how much weight is exerting, so that is usually called as the adhesive weight. So these are the very important definition, and this we have to know, that is accelerating weight, or we call it as effective weight. So that is usually represented by WE, which is usually 10% greater than the dead weight. So in the problem, they usually specify the dead weight and they'll give the rotational inertia. Hence, we could calculate the effective weight. So this is very important. And the tractive effort for the propulsion of train, so that we will discuss in the next video. Thanks for watching the video.